incident matrix A. In a oriented or directed graph, the incidence of elements to a node is shown in a element node incident matrix represented by the letter A, or simply we call this as incident matrix. The arrows in oriented graph indicates the current flow or voltage rise. An incident matrix A has the dimensions of n cross B, where n is the number of nodes and B is the number of branches. For a graph, the incident matrix A is rectangular, that is n cross B. Number of nodes represented in rows, number of branches represented in columns. An entry A ij is equals to 1 if the jth branch is incident and oriented away from ith node, or the entry is equals to -1 if the jth branch is incident and oriented towards ith node, and aij equals to 0 if the jth branch is not incident. We have the bridge circuit, and this is our graph oriented or connected graph. We can say the matrix A is given by the nodes 1, 2, 3 and 4. Nodes here, branches A, B, C, D, E, F. The branch A is going away from 1, so this is 1. The first node consists of A, and D is also going away from the node 1, so going away. But the branch F is coming towards the node 1, so -1, and branch B, C and E are not connected to node 1, so they are zeros. This is one way of forming the incidence matrix. For the second branch, now I am considering the branch to B. B is going away from the 2, so B at 2 it will be +1, and B is coming towards the 3, so 3 for the B is -1, and B is not connected to 1 and 4, so 1 and 4 are zeros. The C is incident away from the 4, so C is incident away from the 4, so 1, and C is coming towards the 3, so -1, and the other terms are 0. Since one branch is having two end terminals, they are known as nodes. For D, D is going away from the 1 and coming towards a 4, coming towards the 4, D, so -1. D is not connected to 2 and 3. Consider the branch E, it is connected to 2 and 4, so, and it is going away from the 2, so away from the 2 and coming towards the 4, so -1, and it is not connected to 1 and 3 nodes, so 2 nodes are 0. F is between 1 and 3, so it is coming towards the 1 and going away from the 3, so the terms are 0. A is in between 1 and 2, 0. So this is our incident matrix. Properties. First one, if you consider the column of branch, for example B, then we have two entries, that is 1 and -1, and the rest are zeros. The information that B is connected between 2 and 3 nodes, and it is going away from the 2 and coming towards the 3. Second, if you consider the row identifies the number of branches incident at the node. At node 3, we have 3 entries, that is B is connected and C is connected and F is also connected. these two are negative, negative and positive. So at node 3, B is coming, C is coming since it is a negative value, and F is going away. This gives the node 3 having the degree of 3 since 3 branches are connected at node 3. So third one. If we get the same entries in 2 columns, this is not happened in this matrix. If we have 2 identical columns, which means 2 paths are there in between the 2 nodes. That means that 2 elements are in parallel. And here, in second point, we can say the degree of the node, and also if 2 branches incident, then the 2 branches are in series. If one row of the incident matrix A is deleted, new incident matrix, that is reduced incident matrix, we can call this A1, having the dimensions of n-1 cross B. Number of possible trees is given by del reduced incident matrix multiplied by transpose of reduced incident matrix. Now let us try to solve this example. A1 is given and we need to find out the incident matrix A and draw the graph. And we know that reduced incident matrix is having the dimensions of n-1 cross B. Here n-1 is 5 cross B is 7. So A must have one more row. That means A must have the dimensions of n cross B. Then this is 1 plus, that is 6 rows and 7 columns. We need to add the 6th row so that we can make A1 to A equals to, from the properties of an incident matrix, that each column should have 2 non-zero entries, that is 1 and -1 and others zeros. Each branch should connect to 2 nodes. So if you examine the first column, our first entry is going away from first node, any of these nodes, so it must go away from the 6th node. Then similarly, if you consider the column 2, the branch is going away from the first node and coming towards the second node, so the last entry will be 0. Here also we have 2 entries, other than that 0. Here also 2 entries, other than that 0. Here also we have 2 entries, other than that 0. If you consider the 6th column, this is also 0. But 7th column, it is going away from the 5th node, it must come to the 6th node. We got the incident matrix nodes, the 1, 2, 3, 4, 5 and 6. Let this be A, B, C, D, E, F, G. Now the first element A is in between 1 and 6. It's coming towards the 1 and going away from the 6. So this is A. Now if we consider the second column, it is going away from the 1 and coming towards the second node, B. And third one, if we consider, it is going away from the 2 and coming to a 5, C. Away from 2 coming to 3. This is our D. Going away from 3 and coming to 4. E. Going away from 4 coming to 5. F. Going away from 5 coming to 6. G. So this is our graph.